Hi, I'm Teacher Thomas. Welcome to A-Level Mechanics. We're looking at the 2020 specimen paper for Mechanics, question 7. Two particles A and B of masses 0.8 kilograms and 0.2 kilograms respectively are connected by a light and extensible string. Particle A is placed on a horizontal surface. The string passes over a small smooth pulley P fixed at the edge of the surface, and B hangs freely. The horizontal section of the string, AP, is of length 2.5 meters. See diagram. The diagram is given on the left. The particles are released from rest with both sections of the string taut. Requirement A, given that the surface is smooth, find the time taken for A to reach the pulley. Requirement B, it is given instead that the surface is rough and that the speed of A immediately before it reaches the pulley is v meters per second. The work done against friction as A moves from rest to the pulley is 2 joules. Use an energy method to find V. For part A, I'm going to use the equation S equals UT plus 1/2 AT squared to find T. For that equation, I need displacement, beginning velocity, and acceleration. I don't have the acceleration. To find acceleration, I'll use equations for tension for particle A and particle B. Starting with B, which is the lead particle, force minus tension equals mass times acceleration. The force is 0.2, the mass times gravity of 10 to get 2 newtons, minus tension equals mass, 0.2, times acceleration. Here's an equation in 2 variables. Now A, the following particle, the formula is tension minus force equals mass times acceleration. Here again we'll be solving for T. The force is 0. A will accelerate, that's resulting from the tension. The force is 0, equals mass of 0.8 times acceleration of A. With some algebraic manipulation, I can set both of these equations equal to T, and I end up with 2 minus 0.2A equals 0.8A. When I solve for A, 2 meters per second squared. I won't go back and solve for tension as I don't need that value for this problem. Instead, I'll continue on to solve for time. S is the displacement, which we're given as 2.5 meters, equals an initial velocity of 0 times t plus 1/2 acceleration we've calculated as 2, 1/2 times 2 times t squared. T squared simplifies to 2.5. Of the 2 resulting values, the only relevant value is the positive, as this is time. Time is approximately 1.58 seconds. For part B, my energy method will be the relationship between potential energy and kinetic energy, showing that potential energy gain or loss is equal to kinetic energy loss or gain. We have a loss of potential energy in particle B as it falls. That loss is 0.2 kilograms times 10 for gravity to get to newtons times a distance of 2.5. Particle B will drop 2.5. That's the same distance that A will move horizontally to reach P, which is equal to the gain in kinetic energy for both particles combined 1/2 times the masses added, 0.8 plus 0.2 times velocity squared plus the given work against friction of 2 joules. Here I'll make an adjustment to the equation that I'm working with. Since we're not conserving all energy, we're losing more potential energy than kinetic energy that we're gaining. That is because of this additional work that's being done, this plus 2. That's gone. That's no longer energy that's in the system. I can simplify to v squared equals 6. I'm only going to consider the positive value. I will assume that I'm moving forward from my starting point, thus a positive velocity of 2.45 meters per second. This completes the requirements for question 7.